So this is my presentation for research tests, which is what do I do with this information. So first thing we're going to be looking at is descriptive statistics. Descriptive statistics is used to describe the basic feature of the data in a study. They provide simple summaries about the sample and the measures. With simple graphs and summaries, they form from quantitative data. Descriptive statistics include mean, median, mode, range, and standard deviation. So the mean is commonly referred to as the average. Median is the middle value of the data. Mode is the most common value in a data set. Range is the difference between the highest and the lowest numbers. And standard deviation is a range around the mean. If there's too much variation in the data set, this will cause the standard deviation to be close to zero. This means that it is more close to normal. This is good as the data will more likely be reliable as there's not much difference between the results. The next thing we're going to be looking at is the distribution curves. This shows a normal distribution curve. It's often shown as an experiment will produce a particular result. The curve is a symmetrical and a bell-like shape, showing trials. Usually gives the results near to the average, but sometimes it will deviate by large amounts. This image also shows the skewness and kurtosis. But that is explained more in the next slide. As you can see, this is the normal distribution as it's symmetrical. This is positive skewness, and this is negative skewness. The next thing we're going to be looking at is skewness and kurtosis. Skewness is where it shows the peak of the curve. Skewness is asymmetric and it is a statistical distribution in which the curve appears distorted or skewed, either to the left or right. Skewness can be defined as the extent to which a distribution differs from a normal distribution. This is known as negative skewness, whilst kurtosis means the sharpness of the peak of a frequency distribution curve. So basically, it tells you how flat or steep the curve is, and how it correlates to the how it correlates to the set of data. So this shows negative skewness as it's near to the right side. This is equal skewness as it's distributed evenly on either amount on the right and left, and this is positive skewness as it is directed more towards the left hand side. As with the kurtosis, the more flat the curve is, it's negative. The more even it is, it's shown as equal, and the more peaked it is shown as positive. The next thing we're going to be looking at is inferential statistics. Inferential statistics are tests for relationships or differences within a data set. This can be seen in basketball and netball, which is shown later on in the next video. It's used to prove the relationships and differences are due to correlations and not by chance. So it cannot just be caused by a chance. There needs to be a reason behind why the relationship or differences are caused by. In Bayes, there is a 5% chance, 5% level of chance that is accepted. This means that there's a 5% chance that you might be wrong, that is caused by. Then inferential statistics is shown over here. There are two types, parametric and non-parametric. Parametric splits off into two branches, interval and ratio, whilst the non-parametric is nominal and ordinal. So if we look into the next bit, the next part, parametric and non-parametric. So there's lots of tests shown over here. So the Pearson's test, the Spearman's test, the t-test, and the Mann-Whitney-U test. And they all test for different things. So the first two shows relationships. They test for relationships within the data set. And the t-test and the Mann-Whitney-U shows the differences in a data set. However, the Pearson's test is a parametric test, and the Spearman's test is a non-parametric, whilst the t-test is a parametric and the Mann-Whitney-U is a non-parametric. Thank you for listening.